Welcome to Defense and Tech World, and thanks for tuning in. Today we're diving into one of the most iconic anti-ship missiles ever built, the AGM-84 Harpoon. Whether you're a defense enthusiast, a student of military technology, or just curious about how Navy's Project Power at Sea, this missile has a fascinating story, from its design philosophy to how it's used in modern operations. Imagine a weapon that can be launched from ships, aircraft, submarines, and coastal batteries, that can find a moving target on the ocean and slam into it with a shaped warhead. That's the Harpoon in a nutshell. Developed during the Cold War, it was designed to give Western forces a reliable, standoff anti-ship capability against Soviet surface fleets. Over the decades it has been upgraded repeatedly, keeping it relevant across changing threats and new platforms. Let's start with the basics. The AGM-84 Harpoon is a subsonic, sea-skimming missile with an active radar seeker. It travels at about 0.8 Mach and typically follows a low-altitude flight path to avoid detection. Its active radar allows the missile to search and lock onto targets during the terminal phase, making it effective against maneuvering ships and in contested environments. Because it flies low over the water, often just a few meters above the sea surface, it reduces radar horizon and complicates interception. One of the Harpoon's greatest strengths is versatility. The original design, produced by McDonnell Douglas, later Boeing, provided multiple launch modes: air-launched variants for strike aircraft like the P-3 Orion and F/A-18, surface-launched versions for naval ships, and submarine-launched encapsulated variants fired from torpedo tubes. This multi-platform flexibility means navies and air forces can share a common missile family, simplifying logistics and training. The warhead is another important piece of the puzzle. The Harpoon carries a high-explosive, semi-armor-piercing warhead designed to inflict catastrophic damage on a ship's hull. Combined with its sea-skimming flight and terminal radar guidance, a successful Harpoon strike can disable or sink surface combatants and large merchant vessels. Over the years, improvements in fusing and guidance have increased its lethality and reliability. Upgrades have kept the Harpoon in service long past its original projected lifespan. Modern versions include enhanced guidance packages, GPS/INS navigation for improved mid-course accuracy, and upgraded seekers to resist electronic countermeasures. Some variants can receive in-flight target updates, allowing launches from greater standoff ranges with corrections provided by forward sensors or aircraft. This evolution illustrates a larger theme in weapons development: a solid base design combined with modular upgrades can yield decades of service life. Tactically, the Harpoon's role is to establish denial zones and threaten high-value surface targets from outside enemy gun and missile range. In naval warfare, commanders use it as part of layered defense and offense, networking Harpoons with ship sensors, maritime patrol aircraft, and drones to create a comprehensive targeting picture. Launching a Harpoon from beyond visual range gives attacking forces a chance to strike before the adversary can close or effectively respond. Of course, no weapon is invulnerable. Harpoons face potential counters like electronic jamming, decoys, and layered ship defenses including short-range missiles and close-in weapon systems. Modern anti-access environments emphasize networked air defenses and long-range sensors that can detect launch platforms earlier. That's why contemporary deployments often pair Harpoon launches with suppression of enemy defenses, deception tactics, and saturation attacks to overwhelm defensive systems. Another interesting angle is the geopolitical footprint of the Harpoon. It has been exported widely to U.S. allies and has seen combat service in multiple conflicts. Many navies selected the Harpoon because it offered a mature, reliable capability with interoperability among allied forces. That interoperability matters during coalition operations where ships and aircraft from different countries need to coordinate under a shared doctrine or through compatible weapons systems. Let's talk about variants briefly, because they show how the family matured. The AGM-84 is the baseline air-launched model. Surface-launched versions have different prefixes, like RGM-84 for ship-launched, and submarine-launched versions are designated UGM-84. Each variant is adapted to the launch environment: encapsulation for submarine launches, booster adaptations for ship launchers, and interface suites for aircraft pylons. These naming conventions help militaries track which variant fits their platforms. In the modern context, the Harpoon continues to be relevant, but it's also being complemented and sometimes replaced by newer systems with longer ranges, higher survivability, or loitering capabilities. Advances in missiles, hypersonics, and autonomous systems are shaping the future of anti-ship warfare. Nonetheless, upgrades and integration with modern sensors extend the Harpoon's operational value, giving many countries a cost-effective and proven option for sea control and denial. For a YouTube video, visuals help make these ideas stick. Show archival footage of test launches, animations of flight profiles and seeker lock-on, cutaways of the missile's internals to explain the warhead and guidance package, and maps illustrating typical standoff ranges and engagement scenarios. Interviews or quotes from naval officers, weapons engineers, or defense analysts can add credibility and texture. B-roll of different launch platforms, aircraft dropping a harpoon, a ship-launched canister, or a submarine firing an encapsulated missile, will highlight the system's versatility. If you want to add depth, include a short segment on countermeasures and defense, how modern warships detect and defeat incoming cruise missiles, what a layered ship defense looks like, and how tactics have shifted to protect high-value units. Then contrast that with how attack planners use networked sensors, multi-axis attacks, and decoys to increase the probability of a successful strike. End the video with a concise summary and a call to action. Recap the Harpoon's core attributes, versatility, sea-skimming flight, radar guidance, and a history of upgrades, and state why it remains important in naval arsenals worldwide. Encourage viewers to comment with their thoughts on the future of anti-ship missiles and what systems they'd like you to cover next. You can also invite them to like, subscribe, and hit the notification bell if they enjoyed the breakdown. Tone and pacing matter. Keep sentences punchy, use visual triggers when describing technical points, watch the seeker light up here, and pause after complex explanations to let the graphics breathe. For narration, aim for a conversational delivery rather than a dry lecture. Imagine you're explaining the system to a curious friend who loves tech but isn't an engineer. That keeps the script accessible while still informative. Closing line suggestion for your narration. The Harpoon has been a backbone of anti-ship warfare for decades. Adaptable, proven, and still relevant, a classic example of how good engineering plus smart upgrades can keep a weapons system effective in a changing world. If you like this deep dive, hit subscribe and let us know which missile or platform we should explore next. That gives a crisp finish and nudges engagement. If you'd like, I can tweak this script to match a specific runtime. Give me the target length in minutes and the speaking pace you want, calm, energetic, or measured, and I'll convert the text accordingly.